Okay, guys. Now let's talk about anti-VM tricks. So now let's talk about techniques that the malware author uses to know if they are running inside virtual machine. And again, these are some of them very old techniques, guys, but it's for you to understand the intention, and you will always learn new ones. Okay, so the first one is virtual machine artifacts. So the malware search for process names, like for VMware, VMware service, VMware tray, for VirtualBox, VBox service, and then they realize they are running inside a virtual machine. Easy one. Okay. Red pill. Oof. Red pill, guys, was probably back in 2010, something around those lines. It was actually pretty cool technique. Let me try to explain you a little bit. I don't want to get you too much confused, but the idea, guys. So what these guys found out is that in Windows there is a interrupt descriptor table register called IDTR, and basically that register holds the base address of what is called an interrupt descriptor table and the size. So basically this interrupt descriptor table, it is being used by the CPU to handle exceptions and even hardware exceptions, errors in the system. Okay, so that base address is being held by this register. So turns out that what these guys realize is that when you are running inside VMware, this value has a unique value, you know? So they realize that VMware always put a unique value because since this is a physical related feature, so VMware just put any value there. These guys understand that, and then by using the SIDT instruction, assembly instruction, they query this register value, and then they realize if it is VMware inside of not. Okay, no pill. Another pretty cool one. Back in the day, that one checks the local description table. This table is actually not being used by modern Windows operating system, and actually was used by 16-bit operating systems, not even in 32-bit. So what the malware authors realize is that when they query this value in modern systems, they realize that VMware was returning a specific value, non-zero. It should be zero because it should not be even used at all. So when they query this value, VMware returns a value, and they say, okay, great, we're running inside VMware, and I'm not gonna give you any hint. Okay. Checking the map shared folders on VirtualBox, pretty easy one, like checking if it is a shared folders inside VirtualBox, CPU ID. This instruction will return CPU features, and it was pretty cool, this one, because when they query inside VMware, it actually returns VMware. That was the name of this feature. And back in the day, what we used to do was like change this value to something else, and that way we bypass this check done by the malware, right? It was a cat and mouse game all the time. I/O communication ports also. So VMware uses I/O ports to communicate with the host and with the guest. The host is the physical machine, the guest is the machine inside the host, which is running the virtualized operating systems, and they realize that these values has actually different values. So VMware uses the hypervisor port 5658 hexadecimal, which can be queried to get the version type. So if EVX contains the magic number VMXH, VMware was present. Again, pretty cool feature. This guy just query, and back in the day you can see assembly with this value, and you realize these guys were checking VMware, if VMware is running. But again, guys, check the detail of understanding of these guys. By the way, virtualization nowadays is not that common. I mean, malware today knows there is probably 50% or more of systems today are virtualized, so there is no more checks on these things. I mean, it doesn't matter if it's a virtual system or not. At the end, it's actually a production one, and is what matters for them. Let's see some quick countermeasures. Quick countermeasures back in the day that we used to use. Patch the response, as I said. Set EAX to 0 after calling is debugger present, and that way, since it's supposed to return 1 if there is a debugger, so then we patch it to 0, and then malware thinks, there is no debugger. That can be done manually, but you can do it automatically. You can call API hooking. We'll see API hooking in the next slides, so that you can automatically, when you see this API, you always return the value you want. You can use plugins like Immunity Debugger, just to be a pretty cool debugger based on Oli Debug, a pretty cool one also, all time, all day. Guys, you just go and Google it. It was an amazing debugger, OLLY Oli Debug. And Immunity Debugger actually was based on Oli Debug, but they added Python support. They never switched into 64-bit debugger for some reason, so it died. Running in a lab without debugger, but monitor with external tools, is another countermeasure, so that you don't have debugger there, but you have other tools so that you can see what is going on. Killing VM related process, easy one, so that they don't find processes running. TLS callback, start debugging at the entry point. Like instead of running in the entry point main module, this just configurations in your debuggers. You start at the system breakpoint instead of the entry point. That way you can break into the TLS callback instead of the entry point. That way you can break into the very first instruction, which is in this case a TLS callback. Exception strict countermeasure. Again, instead of the debugger cutting the exceptions, then just pass it directly to the program, and that way it will run the exception handler created by the malware authors, and that way it's not intercepted by the debugger, and you keep executing it. Okay, here you can see ignore interruption 3, single steps, memory X violations. Just keep running, don't stop. So keep in mind that if the malware does not detect it is being monitored, it will spit out all its malicious actions. That's the actual challenge for you guys, to be able to trick back the malware into thinking it's actually running inside a victim machine. Let's talk a little bit about the packers. The purpose of them is basically three main reasons. The legitimate reason is to reduce the software size. Back in the day, to CD-ROM, DVD media limitations, but it was actually to make it smaller, the programs. Then it was used to protect applications against piracy, and nowadays is used to deter reverse engineering by obfuscating the content of the executable. So today, a program that is packed is almost 90% immediately triggered as suspicious and then malicious. So it's not that common packers for malware purposes, guys. At least not the APT ones, which are more advanced. So normally what the malware authors does is they hide the malicious code until it is placed in memory, and then from there they deobfuscate it, and then trigger malicious actions. Um, every packet has its own decompression or unpacking algorithm. Custom packers are harder to decompress or unpack. And if you wanna do static analysis, you definitely wanna unpack them. And normally you will see many tricks of dumping the raw binary from memory once it is unpacked. Because at the end of the day, sooner or later, they need to be unpacked in memory to run. So you need to wait for them at the right time and let it go. If you wanna debug it, and if you run in a sandbox, then you don't normally need anything unless uh, 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 if the malware doesn't realize it's running inside a sandbox, you know, it will spit out all the details. Common packets, common packers, guys, back in the day, some of them might not exist. Armadillo, one of my favorite ones, is very respected back in the day, 2000s, but discontinued. Temida, one of the best and more difficult, has its own virtual machine and instructions, and today is being used to still is actually pretty solid one. ISPAC, I think, is already discontinued. Enigma was very good one. Empress, I just want to leave you guys these ones for, library for you, you know, uh, so that you can have a historic view of Packers. BM Protect, still running. And NetString, Port.net. Some of the common ones. Confuser, still not very good one, still running there, but easy to see. Maybe we will have some labs to deobfuscate Confuser. How to detect packers? They have their signatures. UPX, for example, is the 101 UPX is the first packer, not the first one, but one of the most traditional ones. It adds two sections to the binary, and the first section 0 is empty. The section 1 has the unpacking code that loads the content of UPX 0 in memory, then jump into it and run. You can use tools like PIDA. I think this tool doesn't exist anymore, but again, it's for you guys to see. Many tools today are being used for detecting packers. XInfoP tool also, if you're gonna get some idea of what the packer is behind, but to be honest, you don't need it too much. There are other ways you are gonna learn how to do it better. This is again a packer attacker. This was a way to unpack. This was a project from Bromium. Bromium used to be a pretty cool company back in the day, probably 2010. And these guys create a unpacker, automated unpacker. When Sandbox came out, like in 2012, there was no more need to do unpacking because it was a cat and a mouse game, right? Like these malicious guys create a packer, and then these antiviruses create the unpacker, and then the antivirus keep updating the unpacker, the unpacker, and the malicious guys keep updating the packer, But when the sandbox came into place, there was no need to unpack anymore. You just run in the sandbox, make sure that it doesn't detect it's running inside a sandbox, spit out all the malicious actions, grab the IOCs, that's it, game over. And then these kind of tools started going down because you don't want to go into the authors, malicious actors game to try to play the game to unpack their packers. Takes a lot of time. You don't want to maintain it. It's not scalable. You just want to get IOCs, add protection, and don't play their game. But anyways, these guys rise to its own P sections, executed with the heap memory that was given executable privileges, able to defeat common packers. Back in the day, it's for educational purposes, guys. It's still there. You can go check it out again for you guys to see these tools that used to be used for unpacking purposes. Okay.